Hey guys, Mr. Cover here. I know that class got away from us today in terms of running out of time, so I wanted to just kind of like slow down, make a little video, talk about some stuff that I wanted to say that I didn't get a chance to fully say in class. So we were talking about all this stuff, it seems like you guys had questions about finishing up this limit definition, so I want to kind of go back to where we were there. Actually, I just want to do a full one together, so let's just do the next one together. So let's do this, use the limit definition to find the area under this curve, to evaluate this definite integral using the limit definition, okay? So let's go through this together. Okay, so you do a limit as n goes to infinity because we want infinitely many rectangles. I do a series because I'm adding all of those rectangles together. The series goes from 1 to n because n goes into infinity and I'm infinitely many rectangles. In here, I do f of a, which is the lower bound of the definite integral, it's the 1, plus b minus a over n with little I times b minus a over n. Again, I cannot emphasize enough that you need to memorize that limit definition of the definite integral. You need to be able to set that up, okay? That's what the AP likes to ask, to make sure that you can set up this limit correctly. Now I need to evaluate it, okay? And this is kind of annoying, but you guys can totally do this. First, let's do a little simplifying. So this is f of 1 plus I over n, 1 over n, still a series, still a limit, okay? F of 1 plus I over n is 4 minus 1 plus I over n squared. Okay, I'm plugging 1 plus I over n in the place of x. I still have a 1 over n here. It's still a series. It's still a limit. I need to FOIL this part out. And I'm going to, sorry, wait one sec. Pull that 1 over n on the outside here. I guess that's probably easiest. Pull that there. I'm going to do the 4. It's going to be minus, and then here I'm going to get 1 plus 2i over n plus I squared over n squared when I FOIL out that green thing. So now I'm here. Okay. Now I'm just going to do some algebra. So I have 4 minus 1, which is 3, plus 2i over n plus I squared over n squared. That's all in the sigma. The 1 over n's out here, and it's still a limit. Now I need to switch it and get rid of the sigma and the i's. And the way to get rid of the sigma and the i's is to use those summation formulas, okay? So we're going to split this all up. Still a limit as n goes to infinity. Still have a 1 over n out here. I'm going to split it up into 3 different sigmas so that I can use my formulas. And also I'm going to pull out the non-I related things. Hope you guys are with me on that part. Okay, I'm just splitting up the sigma among the 3 terms, and then remember n is just a constant, just a number, so I'm just going to pull it out front, because now this looks like all set up to use my summation formulas. Hey, what's the constant formula? Well, it's just the number times n. What's the I formula? It's n times n plus 1 over 2. So I'm going to get 2 times 2 over n times n plus 1 over 2. What's the I squared formula? Wait, sorry, I made a little typo up here. I'm sorry, I just realized something. I forgot the minus to distribute the minus, so these 2 should be negative. I bet. Thank you, guys. What's the I squared formula? It's n times n plus 1 times 2n plus 1 over 6. And I still have a 1 over n squared, so it's really over 6n squared. And I still have this 1 over n out here. And it's still a limit as n goes to infinity. At this point, it's not too bad because I have all n's. This is just a limit with n's. I'm going to distribute that 1 over n in. Do that really quick. Okay, all I did was distribute that 1 over n into the 3 terms, and I'm left with this. And now again, this is a limit you guys know how to do. Okay, the limit of a constant, that's just the number, like, you know, that 3 just stays there. When I'm looking at this term, it's going to be quadratic over quadratic, squared over squared. The leading coefficient on the top is going to be -2. The leading coefficient on the bottom is 2. So the limit as n goes to infinity of that is going to be -1. For the last one, it's cubed over cubed. It's going to be a 2n cubed over 6n cubed. So that limit's going to be a third. Do the math. The answer is 5/3. Again, that is a laborious process. Fancy word there. Miss Lemke taught me that word. A laborious process. You do need to be able to do it for our purposes. It usually doesn't show up in the AP, but we will ask you to do something like this. Okay. If you have a calculator, you can always just plug this in to find the exact area under the curve from 1 to 2 and get out 5/3. As a reminder, just doing like 8 right-hand rectangles or 10 right-hand rectangles would give you an estimate, but it wouldn't give you the exact area. What we found was the exact area. What your calculator tells you is the exact area. What right and left-hand rectangles give you is an approximation, unless you do infinitely many of them, which is what the whole limit definition is. Okay. And moving forward here, I wanted to go back here and just kind of start over on this and talk about this real briefly. What this is saying is we have a graph F. Okay. It's made up of a semicircle and 2 line segments. It's all kind of simple stuff. We're talking about a different function g, and this function g is weird. You input x values into that function g, and what those x values tell you is the upper bound of where you're finding the area of f under. I said that kind of weird, but it tells you the upper bound of the definite integral. So when you do g of 2, you plug in 2 for x, and that means find the area underneath f of t from 0 to 2. So the x value you are plugging in is telling you where to go to find the area. We're always starting at 0, but it tells you what the other x value is. It tells you the b. It tells you the upper limit of integration. Okay. So to actually do g of 2, you do the area under the curve from 0 to 2 of this graph. Now, how do you do that? Oh, well, this graph is geometric. It's all the shapes are geometry shapes, so I can actually find these areas. That blue region's a semicircle. It's a semicircle of a circle with a radius of 2, so the full area would be pi r squared. It'd be 4 pi, but it's just a quarter of that circle, so it'd be pi. G of 0 would be find the area under f from 0 to 0. Well, I'm not even going to look at the picture. The area from 0 to 0, that's just 0. I'm not even moving. This last one's a little tricky. The area from 0 to -2 of f under f of t. Oh, this is one of those ones where the lower bound's bigger than the upper bound. I'm moving backwards. So I'm going to need to toss down a negative. Okay? Well, let's find the area from -2 to 0. And then make it negative. -2 to 0, that's just pi again, because it's just another quarter of that circle. But since I'm moving backwards, I need to say it's -pi. The other way to think about that would be to look at that definite integral and say, wait. I gotta have the lower number on top, and then put a negative out there. That's what a lot of people do. Oh, I'm gonna find the area under the curve from -2 to 0, and then I'm gonna make it the opposite of what it was. Okay. Last thing I'd like to do, take a look, ignore the g of x thing now. Take a look at this same picture, try to evaluate these 3 definite integrals. Go ahead and take 30 seconds to do that. Ignore this, you don't need this. There's a picture, do these 3 definite integrals. Oh, and can you also do this? All the way from 0 to 5. Okay, take 30 seconds, or like a couple minutes. Okay, so to run through these, from 2 to 4, well, it's just a triangle. You find that triangle. Triangle is an area of 1, but since it's below the x-axis, I have to make it negative. For E, it's the same thing as D, except for my bounds are backwards, which means it's going to be the opposite value of whatever D was. We said D was -1, so E is +1, okay? So since it's under, I wasn't sure if you guys hear me, since it's underneath the x-axis, but it's also backwards, those negatives cancel each other out, that's why it's +1. For F, from 3 to 5, if you look at an x value of 3 to x value of 5, you have these two different regions. Both of them have an area of 1/2. But since one's below and one's above, they cancel each other out, and the value of that definite integral is 0. For G, you got to do the whole thing, all the way from 0 to 5. So you got a positive pi, you got a -1, and you got a +1/2. So you do pi minus 1 plus 1/2 is pi minus 1/2. You're kind of putting all those regions together. Cool. All right, I hope that helps clear up a little bit. If you have questions as you review, just email me. We'll figure it out. Thanks, guys.